Let's start by defining an error boundary, a React component designed to catch JavaScript errors in their child component tree. We begin with a class component named errorBoundary, with a constructor initializing state to indicate whether an error has occurred. In getDerivedState from error, a static lifecycle method, we update the component state when an error is caught, signaling that we should render a fallback UI. Note that this lifecycle is triggered whenever a descendant component throws an error. We also implement component didCatch, another lifecycle method, which allows us to catch errors for logging purposes. Finally, our render method checks if there has been an error. If so, it renders a simple message indicating something went wrong, otherwise, it passes through the children components normally. Now, let's use the power of code splitting in React. With the React lazy function, we create a lazy component. This is a dynamic import, which means it will not be loaded until it's needed, reducing the initial load time of our app. The import function within React Lazy returns a promise which resolves to the module exporting our component, which in this case is lazy component. Within our application's render method, or inside a functional component, we use the error boundary component we created earlier to wrap around React's suspense component. Suspense accepts a fallback prop, which allows us to render some fallback content, such as a loading spinner or message, while we're waiting for our lazy component to load. Inside suspense, we then render the lazy component. If an error occurs while loading the component, the error boundary will catch it and render our error message defined in the fallback UI. This prevents the entire app from crashing due to an error in a lazy loaded component.